Hello everybody and welcome back to our packet sniffer. And in the previous video we performed the analyzing of our IP header, and what we want to do right now is check for our TCP_UDP variable whether it contains TCP or whether it contains UDP. So what we did right here, as you can see from the actual previous videos, we actually changed the IP bool or checked the IP bool. If IP bool was true, we actually went to the analyze IP header function, and right now we are not actually checking the IP bool anymore. What we are checking is the TCP_UDP variable. So down here, since we returned the TCP_UDP into this variable, we can check what we got. So if TCP_UDP equals to the string of TCP. Now why we are specifying the string of TCP is because we returned right here we set the TCP/UDP variable to be equal to TCP if IP protocol was equal to 6, which is the number for the TCP header. And right here, all we want to do is check whether it is TCP. If it is, we want to process or proceed to returning the data_receive to be equal to the function analyze _TCP_header from that data, so from data_receive. Else if TCP_UDP will be equal to actual UDP, we want to proceed with the data receive to be equal to analyze _UDP_header from the same data receive. Now we know that this data receive actually returned the data stripped from the IP header, so all we will be left to have is the TCP or the UDP header in our case. In any other case, we will just return from our function, and then we can down here call our program to be while true main. Now the reason we are using while true is basically because we want to run this for infinite amount of time, or not infinite, until we actually stop the program, so we can sniff for the packets for as long as we want. So let me just double check everything. Okay, everything should be good to go. Let us actually check our program if it is running right now. Let us put everything under the hash. Let's see if we can run the program, if our main function is good. So we will perform this, then we will go right back. And let us see if we can run the program right now. I'm not really sure, but we can give it a try just to see what we will get. So we run the sniff packets. We can see there is invalid syntax. Okay. Let us see where the invalid syntax is. Okay, so we are missing the 2 dots at the main function, so make sure to specify that right here. Save it once again. And we can see that we get printed the Ethernet header and the IP header. We can see everything is printed in the good format. We get the destination MAC address, the source MAC address, the protocol number, the version, the source IP, destination IP, we get everything. And once a new packet arrives right here, we should be printing the new packet as well. But I can't seem to actually see a new packet arriving. Let us try to refresh this page, for example, and we can see we are getting a bunch of new packets right here. So everything is good to go. We can see everything is changing. Our program works really well for now on. Now what we want to continue is what we started, which is the TCP/UDP header, so nano sniff packets.py. And let's make a first function which it can be the actual, for example, TCP function. So we can code the TCP header first, since that will be a bigger header. It has more fields than the UDP. So let's do it first. Def analyze _TCP_header, and in that function we paste the argument data_receive. We don't forget to add the 2 dots. And right now what we can do is actually perform the same task as the IP and Ethernet header. So we want to strip from all the fields, and we want to first unpack the actual header. So TCP_header equals struct.unpack, and what the pattern for this will be is something like this. So 2h 2i for h. Now I'll show you why in just a second. So what we will do is we will actually try to find the same picture for the TCP header that we actually had for the IP header in order to see how many size or what size do certain fields take and how many of them are there. Now what we want to strip from is actually strip from the data underscore receive the 20 size, so the same as in the IP header. And you can see that the first new thing that we have right here is the I variable, or not variable, the I letter right here, which basically stands for the actual full length. So let us put this as a smaller window. Let us enlarge it like this, and we are not really interested in the list of protocols. We don't want the TCP header structure. What we want, or pardon me, the IP, what we want is TCP header structure. And we can open the any actual picture that we might get. So here is one of them. We can see the actual available fields for the TCP header format. So the first of all, we will have the TCP, the source port and destination port, which if you are familiar with the previous header, you will know that both of these will take actual 2 spots, or basically an entire element in our TCP header list, since the first 2 letters that are specified are the 2H, and 1H will each represent one field right here. So the first H will represent the source port, and the second H will represent the destination port. Now this I variable right here, as you can see, there is 2I. They represent the full length, as I said, so you can see that the sequence number and the acknowledgement number are actually the full length. So we will store both of them in the I, or we will extract them by the I, and we will store them in some variable that we will name later on. And then further on we have the 4H, so what we will have to do is these 3 parts right here we will have to split into 1H. The window will take an entire first H, the checksum will take an entire third H, and the urge pointer will take an entire fourth H. And these options right here we are not actually concerned about. So that is how we split the TCP header. So let us actually continue with, first of all, the source port and the actual destination port. So we unpacked our TCP header. Source underscore port takes an entire actual element, so TCP underscore header. And then the first element, the same we want to do for the destination port, equals TCP underscore header. The second element, the sequence number, takes the same, so we specify double I, which is the full length, so we can specify them as the entire element, so seq underscore num equals TCP underscore header third element, and same for the ACK number, equals TCP underscore header and the fourth element. Now you will see that the next thing we have is another H, so these are the 3 fields that we need to split into that H. These are just some flags, and these are basically the actual offset and the reserved. So what we will do is we will actually perform the same logical expressions as before in order to split them up. First of all is the actual data underscore offset equals TCP underscore header. The fifth element, header, fifth, not P. Why do I continue typing P? Okay, so 4. And then what we want to do is actually move that or shift that with the 12 bits. The next one is the reserved. Let me see if it really is reserved. It should be, I believe. Reserved. Okay, so it is reserved. We will just call it just like that. Equals, and since that one is the middle, we need to perform actual multiple logical expressions or shifting parts. The header, the fifth element, we need to shift it 6 bits. And then what we need to do is end it to the actual, where is okay, so here it is, 0x03ff. So after that, we are left with one more, which will be the flags, which we will need to actually split all of them one by one. But for now, let us just add the flags variable to be equal. So flags equal TCP header And since that is the last element, all we have to do is end it with the 0x003f. After that, everything is good to go, and we only need to separate these fields into each element one by one. So we have 3 left, so let us finish them. Window is the next, equals TCP underscore header, 7th element, or pardon me, we are not there yet, so 5th element or 6th element, and then the checksum, which we also had in the IP header, will be equal to TCP underscore header, 7th element right now. And we are left with the urge underscore pointer, or let me just check it out. Okay, so urgent pointer equals TCP underscore header, and then the last one, which is the 8th element. And we extract the data. Data equals data underscore receive from the 20 to the end. Okay, so everything is good to go. And now you might notice that actually this header right here has some weird spot right here, as you can see. And basically what these are basically flags. So there are different types of flags, such as urge, ACK, SYN, FIN, and you can see a bunch of these others, or not bunch, just the REST and PCH. What we need to do is actually split them, and we will split them by their actual value. So in order to perform that, or in order to actually add the flag to its variable, we will need to make 6 different variables, each variable for each flag, and we will have to perform the boolean and logical expression with the specified bits from these flags in order to check which flag we have in our packet. So in order to do that, just go down here. First one is the urge equals bool flags, and where is the sign? Can't seem to find it, and 0x0020. Oops, what am I typing? 0x0020. Close the brackets. The next one will be ACK flag, so the same thing we need to perform. We are using the flags variable because the flags variable is storing that value right here, and we need to use it in each of these flags. Once again, I can't seem to actually type. Close the brackets. PCH is the next one. Let me just check it out. Okay, so PCH really is the next one. So flags 0x0008. 3 more left. And then we are good to go, and we can print everything and continue to the UDP packet in the next lecture. The next one is the SYN one, equals bool flags 0x0002. And after we finish actually all of this, including the UDP header, we will be having a full packet sniffer, which will split each field of the packet that we receive. So this is not really something useful for hacking, as I said before, but it is good to actually test your knowledge, not test your knowledge, but to learn new things and to learn more in depth about packets and their headers. As we can see now, we know that the packet can contain Ethernet header, which can have attached the IP header to it, and then further on, which can have attached the TCP or UDP header. And then we also split all of those headers into different fields, so we know what fields does which header have. It is something useful to know. You never know when you might need something like that. And all we want to do is, in the next video, we want to actually print all of this that we typed right here, and we want to do some actual expressions in order to finish the analyzing the UDP header, which will be smaller than the TCP header, so don't worry. After that, we will test our program to see if it will work, and if it does work, we can continue to the next section where we will code our reverse shell, which will be multifunctioning reverse shell. And then we will code after that the threaded server, which will accept multiple connections. Right after we code the actual server, which will accept only one connection. And then we can actually see how we can make our own command and control center, which can take the input or the connection from multiple PCs, and we can interact with all of those PCs as we like. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one. Bye!